Algebra 1, Lesson 104, we are looking at how to solve our quadratic equations one more time. And in this case, we are using something called completing the square in order to form a perfect square trinomial so that it's much easier to solve quadratic equations that often don't have whole number answers, whole number solutions. So remember what a perfect square trinomial looks like. We start out with a binomial that has been squared. And so if we have x minus 7 squared, that means, and remember this is a pattern, so we have the square of the first and the square of the second, so negative 7 times negative 7, so plus 49. And then we're going to multiply the two terms together and multiply by 2, which means I'm going to get negative 14x. And so that's what I'm looking for in order to create these perfect square trinomials. And like in the second one, I would get x squared plus 6x plus 9. Completing the square means we are forming a perfect square trinomial. And the reason that we do this is sometimes we have equations that are super close to being perfect square trinomials, but we need to add a little bit to each side in order to get that binomial squared. So what we're going to do is, let's start with the right side one, and we would say x squared plus 6x plus something is going to give me a perfect square trinomial. Well, if you remember from just the last page, this would be a 9 in order to be a perfect square trinomial. But the question is, how do we get that regularly, especially with ones that are a bit more difficult to see? Well, and it comes by looking at this 6x. Because if we were to multiply the binomial, we would end up with plus 3x and plus 3x, giving us that plus 6x, which means that a 3 is involved, okay? And it's actually this x plus 3 squared that is our binomial squared. So that 6 is really key because I take it and I divide by 2, so I can get those two pieces. And then in order to get what I have to add to this, I need to take that and I need to square it, since that's what we're going to do that. 3 times 3 gives us 9. So in this kind of more general case, x squared plus bx plus something, I'm going to do the same thing. I'm going to take b and divide it by 2, so it's in those two pieces, and then I'm going to square it. And that's what's going to give me my perfect square trinomial. Okay, and if I were to factor this one, x squared plus bx plus b over 2 squared, I would say this is x plus b over 2, all of that squared. And if we were to multiply it out, you will see that we do get x squared plus bx plus b over 2 squared. So let's just practice adding to these and completing the square. So if I have x squared plus 8x, I'm going to take 8 divided by 2, and then I'm going to square it. So I have 4 squared, which is 16. So I would have to add 16 in order to complete the square. Okay, or these ones, x squared minus 12x. Well, I'm going to take that negative 12, divide it by 2, and then square it, which means I get a negative 6 squared, which is plus 36. There we go. And this next one, I'm going to take 24, divide it by 2, and then I'm going to square it, which means 12 squared, so 144 is how I would complete the square. Now this may seem just kind of random. Why are we adding things to complete the square to make a perfect square trinomial? Well, it's because of situations like this. X squared plus 10x equals 11. Now this one is one that we could use our normal methods and get one side equal to 0. So x squared plus 10x minus 11 equals 0. And we could factor to say I have x plus 11 and x minus 1 equals 0. We could do that so that we could say my answers are negative 11 and 1. But in most situations, actually, and in all of our real life situations, basically, this is very hard to do and very lucky to get something like that. So we use a system called completing the square in order to do this. And we should get that negative 11 and 1 as our answers. So let's complete the square. And what I want to do is, using those skills that I just learned, I want to complete the square on the left side. X squared plus 10x plus something should be a perfect square. And if we do the same thing, 10 over 2, and I'm going to square it, that means that I'm going to have to add 25 to each side, not just the left side, because this is an equation, I have to add it to both sides. which means I'm going to do 11 plus 25. I'm adding these pieces here. Okay? Now if I add the same thing to each side, I'm not really changing the equation, but I can go ahead and simplify the right side, and I can factor the left side to get x plus 5 squared. Now if I were to give you this equation originally and say solve for x, one way you could do that is by undoing this squared, by square rooting each side. Big thing here though is to remember, if I get x plus 5 on the left side, I have two possible answers on the right side. Because if this is an equation, I have a plus or minus 6 on that right side. And then I can go ahead and separate this to say x plus 5 could be 6, x plus 5 could be negative 6, which means I'm going to subtract 5 on each side, so get x equals 1 and x equals negative 11. Exactly what I found using my original methods, but this is much more powerful for lots of different types of quadratics. Okay, so completing the square. Let's try it again. The more we see, the easier it will become. So x squared plus 12x, that means that I need to do 6 squared as what I add, so I do x squared plus 12x plus 36 is equal to 13 plus 36. So I am going to factor the left side and get x plus 6 squared is equal to 49. I'm going to square root each side, get x plus 6 is equal to plus or minus 7. Remember, we're finding the solutions for these quadratics, or finding the x-intercepts. So when I say that plus or minus 7, it's because I can have two different solutions. So we have x plus 7 and x plus 6 equals 7 and x plus 6 equals negative 7. I'm going to subtract 6 on each side, get x is equal to 1, x is equal to negative 13. Meaning that if I were to see this quadratic on a coordinate plane and I had negative 13 here, I had 1 here, I would have this quadratic that would be going through these 2 points here. That's what I'm finding right now. Those are my solutions. All right, let's just do a couple more here. And sometimes you can see these and they start out a bit different. We have to have a coefficient of 1 on this x squared. Right now it's a coefficient of 4, which means I have to get rid of that 4, and the only way that I can do that is by dividing 4. Now I have to divide by 4 with everything here, which means I get an x squared plus, plus 4x equals 2. And now I can complete the square by, in this case, I have to add 4 to each side. So I'm going to factor the left side and get x plus 2 squared is equal to 6. And then I'm going to square root. Now you'll notice that square root of 6 is not going to be a whole number. That's okay. I can still say x plus 2 is equal to plus or minus the square root of 6, which means that I can split this to say x plus 2 is equal to root 6, x plus 2 is equal to negative root 6. And I can solve for x. X is equal to, well, subtract 2, so negative 2 plus root 6, and x is equal to negative 2 minus root 6. The other way that you could write this is going from your original down here and subtracting 2 from each side and having x is equal to negative 2 plus or minus root 6. And just knowing that that is two different unique solutions. Okay? Here we're going to have to divide by 3 and get x squared plus 4x is equal to 14. And then I'm going to have to add 4 to each side, so x squared plus 4x plus 4 is equal to 18. I'm going to factor x plus 2 squared is equal to 18 and square root. So now the square root of 18 can be simplified. So we can say x plus 2 is equal to plus or minus 3 root 2. And then I can subtract 2 from each side. Get x is equal to negative 2 plus or minus 3 root 2. And that is my those are my two different solutions for my quadratic. All right, we'll just do this 1 or 2 more here, and then we'll be done. So the length of a rectangle is 12 feet more than its width. The area of the rectangle is 64 square feet. What are the dimensions of the rectangle? Okay, So if I say I have this rectangle that has a width of x and a length of x plus 12, well, we could say x times x plus 12 is equal to the area of 64, which means if I have x squared plus 12x plus, let's see, we need to add 36 to this. Well, we get 100 on this left side. We can factor x plus 6 squared equals 100, which means I get x plus 6 is equal to plus or minus 10. So I'll subtract 6 and get x is equal to, let's see, negative 6 plus 10 is 4, or x could be negative 6 minus 10, which is negative 16. Now, which one makes the most sense? Well, if we're talking about dimensions, 4 is going to be the only one that makes sense here. Theoretically, this quadratic has another solution at negative 16, but in this context, we would just say that our solution is 4. Here's another couple that you can try here, okay? And make sure that your x becomes, x squared is just a 1x squared. And here's one more that you can try. All right, well, I hope this is helpful for your homework and for studying.